I am Dr. Gaurav Saxena. I am Associate Professor in EC Department and I taught the Fundamental of Electronics Engineering BEC V101 and my topics is Diode Application and Rectifiers. So what are the rectifiers? Rectifiers are those circuits who convert alternating current to the DC current. So that means AC to DC conversion is called the rectification. So rectifiers are three types: half wave rectifier, full wave rectifier, and bridge rectifiers. So what is the features of half wave rectifier and how we calculate what is the DC voltage, peak inverse voltage, what is the efficiency of half wave rectifier, what is the ripple factor of half wave rectifier. So we calculated here. So this is a half wave rectifier circuit. This is the input signal we have to be applied here. This is diode where P is here, this is N is here, this is the load resistance where the output voltage is to be taken at the load resistance in the positive half cycle, because this is the AC signal. During the positive half cycle, that particular potential is plus and this is minus. Then this diode works as a forward bias. They allow, so that means if diode is ideal, so they behave like a short circuit, so they allow that particular signal and we taking this signal to the load. So that means they allow the positive half cycle, but when negative half cycle is to be here, that means this terminal is negative and this terminal is positive, then diode works as a open circuit, because this diode P is to be connected at the negative terminal of the voltage, or that means in that particular duration diode D works as a reverse bias. So that means reverse bias, what is the meaning of reverse bias? This diode works as a open circuit, so no current flow. So that in that particular circuit only half wave to be rectified from AC to DC. So we can say this is a half wave rectifier. This is the circuit diagram. This is short circuit during the forward half cycle, and this is the output voltage, which is exact replica of input voltage in the during the half cycle. But in the case of negative half cycle, this blocked this particular signal, because in that particular signal, when we apply a negative half cycle at the terminal input terminal, the diode is reverse bias. In that case, the diode is forward bias. That means diode works as a open circuit in that particular duration in short circuit, so no current flow. So we can say this is a half wave rectification circuit. So we can say this type of rectifier is called the half wave rectifier. And this is a positive half wave rectifier, but if we required a negative half rectifier, so the orientation of diode should be opposite to the previous one. So that means in this case, this is a half wave rectifier, positive half wave rectifier circuit. This is the positive half wave rectifier circuit, but in the case of negative half wave rectifier circuit, that means in the when positive half cycle is to be here, because this is N terminal, this is P terminal, this N terminal is to be connected to the plus. So we can say this diode works as a reverse bias condition. So they behave like a open circuit, so no current flow. But in the case of when negative supply is to be here, that means N is connected to the negative. That means silicon diode is work, or germanium diode or PN junction diode works as a forward bias condition, and that means this diode works as a short circuit. So current is flowing from this diode to the load, and we achieve a output in the negative half cycle. So this diode, this type of circuit is called the negative half wave rectifier circuit. You have to see that. So in a half wave rectifier circuit, what first is how we calculate the root mean square voltage. So what is the meaning of root mean square voltage? Root mean, so if we say this is a V is equal to Vm sin omega t, this type of voltage we have to be applied. This is the input voltage. So how we calculate the root mean square value? So root mean, that means the what is the this voltage Vi square, Vi square, that means the Vm square sin square omega t. In the, if we differentiate integrate it, d omega t because in a half wave rectified circuit only first half is to be rectified and second half pi to 2 pi there is no current. So, we apply the limit 0 to pi, and what is the mean, that means the, because the whole of the cycle of input signal is to be defined in the 0 to 2 pi. So, we divided by 2 pi. So, that is the mean. So, if we calculate it, this is Vm by 2. So, what is the root mean square value in the half wave rectifier circuit? Which one is Vm by 2, where Vm is the maximum voltage. If I can say, if we apply a 2 sine omega t 314 t signal is to be applied then in a half wave rectifier circuit, then if we find a what is the Vrms, so that means Vm by, that is Vm is 2, Vm by 2, that means 1 volt. So, we easily calculate the, by using the formula Vrms is equal to Vm by 2 for half wave rectifier circuit. Second, in the second case, we calculate the what is the average voltage. So, yeah, DC voltage or average voltage of half wave rectifier circuit. So, what is the average voltage? So, what is the area covered by, area covered during half cycle upon total time. This is the formula to calculate the average voltage or DC voltage. Average area covered, how we calculate the average area covered? Average area covered, that means integral 0 to 2 pi Vi d omega t. Vi, what is the Vi? Vi is equal to Vm sin omega t d omega t. So, Vm sin omega t d omega t, because this is a half wave rectifier circuit. So, only signal is to be rectified from 0 to pi. So, we divided this signal into the two form 0 to pi Vm sin omega t d omega t plus pi to 2 pi Vm sin omega t d omega t. But in the case of positive half cycle rectifier, half wave rectifier circuit, in this case p to 2 pi, pi to 2 pi, no signals to be in the output waveform. So, that means this one is 0. So, we can say 0 to pi Vm sin omega t d omega t, and the total time is 2 pi. So, we calculate it. So, the value of this is Vm upon pi, or we can say 0.318 pi. So, we easily calculate what is the DC voltage or average voltage of a half wave rectifier circuit. Ripple factor. So, what are the ripple factor? Ripple factor is to be calculated by the this formula Vrms upon Vdc ka whole square minus 1. So, in this case, half wave rectifier circuit, what is ripple factor? How much AC component is to be appear in the rectified output, which can be measured by the ripple factor. So, more ripple factor, that means that the pulsating is DC is to be here. So, we required a ripple factor should be 0 for pure DC configuration, but in the case of half wave rectifier circuit, what are the ripple factor? So, ripple factor we easily calculated by what are the Vrms upon Vdc ka whole square minus 1. So, we easily calculate in the previous slides what are the Vrms for half wave rectifier circuit, which one is Vm by 2, and what is the Vdc or V average, which one is Vm upon pi. So, we put this value in that particular equation number 1, then we easily calculate the ripple factor, which one is 1.25, 1.21 for half wave rectifier circuit. And very important parameter, which one is efficiency. So, what is the efficiency in terms of the rectifier circuit? So, rectifier circuit, that means the what are the DC power out in the output stage and what is the AC power you have to apply in that particular rectifier circuit. So, that means the P output upon P input is the rectification efficiency, because P output in terms of the DC, because this is a AC to DC converter. So, P output is P DC, and what is the input signal? Input signal is AC. So, P DC upon P AC is the rectification efficiency. If we multiply by 100, so what are the percentage of that particular efficiency of any half wave or full wave rectifier circuit we have to be calculated. So, how we calculate the AC? PAC? PAC is to be calculated by this formula. This one is IRMS ka whole square RF plus RL, because the forward resistance of diode is to be taken in account, because this is the practical diode. But in this case, if RL is very much greater than RF, small RF, so we ignore it. So, we easily calculate the IRMS ka whole square into RL. So, what is the value of PAC? IM, because IRMS is for half wave rectifier circuit is IM by 2. IM by 2 we have to be calculated. IM by 2 ka whole square RF plus RL. What is the PDC? PDC we have to be calculated IDC ka whole square, because this is a DC current. So, we apply a DC voltage or DC current, IDC ka whole square into RL. IDC, what is the I average? IM upon pi. So, V average we have to be calculated. So, in that particular fashion we have to calculate the IDC. IDC is equal to the IM upon pi. IM, what is IM? IM is the maximum current which have to be flow in that particular circuit. IM by pi ka whole square into RL. Then we put this value into this particular equation, parent equation. Then we calculate the efficiency of half wave rectifier circuit is 40.6%. That means only 40.6% of input AC to be converted into the pulsating DC. This is a half wave. What is PIV? This is the peak inverse voltage. So, what maximum voltage we have to be applied at the reverse bias condition in a PN junction diode, in that particular diode where your diode works significantly and not to be destroyed, that particular voltage is called the PIV. For any rectification purpose, for half wave rectifier circuit, the PIV ratings to be greater than and equal to the maximum voltage. So, we easily calculate it by this diagram. So, full wave rectifier circuit is to be tailored by in two form: full wave bridge rectifier circuit and the center tape full wave rectifier circuit. So, this is a bridge rectifier circuit. What is the meaning of bridge? So, this is a Wheatstone bridge just like this. So, we can say if we placed a diode in that particular fashion, so we can say this is a full wave bridge rectifier circuit. In that particular full wave rectifier circuit, both positive and negative waveform of inputs to be rectified at the output terminal. When we apply a positive supply in that particular terminal, so we can say D2 is forward biased, because plus terminal is to be connected at the P type of diode, and this one is N type. So, this is reverse bias during the positive half cycle, and this negative terminal is to be applied here. So, we can say this is forward bias, and N type is to be connected to the negative terminal. This is forward bias, this one is reverse bias, or we can say this is open circuit. So, this current is to be flow from this side to this side, it's just like this. So, but in the case of if we apply in the next cycle, this is negative, this is positive. So, this one is forward bias, this one is forward bias. So, in this case, this diode works as a just like a current flow in that particular circuit, or we can say maximum current flow in that particular circuit. You have to see that in that particular when this terminal is plus, so current is flowing here, but in this case the current is flowing here. So, the whole of the rectified output is to be flow. That means this one is from D2 and D3 forward bias, this one is D1 and D4 is forward bias. So, this is a full wave rectified output is to be made in bridge rectifier circuit. This is a center tape rectifier. That means in this particular circuit, this is a transformer, and we apply this transformer, the center tape. What is the meaning of center tape? The voltage to be divided into the divided by in two forms, just like that means if this is Vi. So, if we taped at the center, so this voltage and this voltage to be same, because the diode is to be same. So, we can say same voltage is to be applied in the D1 and D2. When this plus voltage is to be applied here, so D1 is forward bias. When negative is to be applied, D2 is reverse bias, so current is flowing in that particular fashion. But in this case, if plus is applied here, negative is applied here, in the particular case D1 is reverse bias and D2 is forward bias, so current flow in that particular fashion, so rectified output is to be made. You have to see that. In that particular case, when we apply a positive terminal here, so this is open circuit, this is short circuit, so rectified output here. But in this case, when negative supply is to be here, so in that particular case, this one is open circuit, this one is short circuit, so rectified output is to be met here in that particular duration Ty2 to T, and that particular duration upper circuit is to be given a rectified output in the range of 0 to T by 2, but a lower circuit is to be worked when your input voltage is to be applied at and the rectified output is to be met at the T by 2 to T. So we easily calculate the RMS voltage here in the same fashion, Vi sin omega t ka whole square upon total time period. So we calculate it. So this one is root mean square value, which one is Vm by root 2. So in the full wave rectified circuit, the root mean square value is Vm by root 2. And how we calculate the average voltage? Because the time period is pi. Because why we can say this is the time period of pi? Because this is the rectified output 0 to pi. They change the their value after the pi time. So we can say the time period of full wave rectified output is pi. So Vm upon pi sin omega d omega t. So we calculate it. This one is 0.636 Vm. So what is the average voltage? Average voltage we have to calculate by the area under the curve upon total time. So area under the curve, that means we have to calculate by Vi d omega t, that means Vm sin omega t d omega t 0 to pi and pi to 2 pi. So we easily calculate this calculation, and we easily calculate what is the value of this 0.636 Vm. So in this case, for full wave rectifier circuit, the average voltage is 2 Vm upon pi, and we calculate the ripple factor in full wave rectifier circuit. So IRMS upon, so VRMS upon VDC whole square upon -1. So if we applied the root mean square value is Vm by root 2 and VDC is 2 Vm upon pi. So that if we put this value in that particular equation, so we calculate 0.48. So you see that in full wave rectifier circuit, the ripple factor is 0.48. But in the case of half wave rectifier circuit, the value is gamma is 1.11. So if we compare that, that means in the half wave rectifier circuit, the more ripples is to be appear in the output circuit, output waveform. So rectification efficiency, which is calculated by PDC upon AC. So we see that the rectification efficiency is 2 times, because 2 diodes and 4 diodes to be appear. That means the whole of the cycle they rectified it. So the efficiency of full wave bridge rectifier or center tape rectifier is to be 81.2%, which is doubled at half wave rectified circuit. So, but in the half wave rectified circuit, what is the efficiency? Which one is 40.6%. That means the output power is to be less to be rectified in half wave rectified circuit, but in the case of full wave rectified circuit, which one is 2 times of half wave rectified circuit. So how we calculate the PIV in bridge rectifier circuit? So we can say this is PIV is calculated. So what is the PIV? So we appear at, so the what is the voltage? So this voltage to be this is short circuit, and the voltage is Vm is to be appear here. So in bridge rectifier circuit, if we calculate in particular loop, so PIV is greater than Vm. But in the case of central tape rectifier, so if we take in this one is open circuit, so what is the PIV, peak inverse voltage? Because peak inverse voltage always calculated in the reverse bias condition. That means this diode is to be work at the reverse bias. So we can say this terminal, P terminal is to be negative and N terminal is to be positive. So this is reverse bias condition. So what is the PIV voltage we have to calculate it? In this case, this one is short circuit. This is short circuit because at that time this diode works as a forward bias. So we have to see that this is Vm, this voltage is Vm, and in that particular circuit this voltage also Vm. So we calculate in center tape transformer, center tape full wave rectifier, the PIV is secondary voltage. So what is the secondary voltage? This one is Vm. And what is the voltage across the resistance, which one is also Vm. So that means if we design a rectifier circuit for central tape full wave rectifier circuits, so PIV is choosing as a greater than or equal to the twice of Vm for avoiding the destroying the to avoid the destroying the diode. So this is the comparison of rectifiers. In the half wave rectifier, one diode is to be sufficient, but in the full wave rectifier, for center tape 2 diodes is sufficient, and bridge rectifier 4 diodes is to sufficient. Maximum efficiency kitni hogi? What is the maximum efficiency for full wave? 40.6. In this case 81.2. What is the ripple factor? Ripple factor is 1.21, and ripple factor in full wave rectifier is to be half, 0.48. Voltage regulation is good. Better is compensated of half wave rectifier. So this one is the voltage regulation. That means the output voltage to be fixed and without disturbing the input and line voltage. What is the peak inverse voltage? This one is Vm, and 2 Vm for central tape transformer. What is the average voltage or DC voltage? For half wave rectifier is Vm upon pi, and the full wave rectifier is 2 Vm upon pi. And the root mean square value voltage is Vm by 2, and in this case is Vm by root 2. So whole of the rectifiers is to be covered. Thank you.